I would like to welcome for the classes we are trying to schedule via different online mediums. We'll try to make it as relevant, as easy, and as approachable as we can. I need your cooperation because we are trying this for the first time. We'll just see how can we make it more and more accessible to all the students. Right now, I just wanted to begin our classes with the revision of few topics which we have covered in our previous classes in the college, where we have already studied about the introduction of organic chemistry, where in introduction we have seen the basic definitions of organic and inorganic chemistry. We have also seen the reasons why organic and inorganic chemistry are studied separately. We have various reasons listed out in our notes, so I will advise you all to just look into those notes which we have already written. We have also come across a term at the end of that introduction class, that is catenation, which is associated with carbon. And we should know this, that, and I believe all of you remember it, that carbon has a capacity to link with itself, that is carbon. So it can link with itself to n number of atoms. This is the major difference in numbers why organic compounds are in millions and inorganic compounds are in few thousands to hundreds. So this is what is the essence of our introductory class, where we have concentrated on basic definition of organic and inorganic chemistry. We have also sorted out various examples of organic and inorganic chemistry. We have seen the reasons why we are studying organic and inorganic chemistry separately, and also we have concentrated on the term that is catenation, which is nothing but self-linking. What is self-linking? It is self-linking between carbon and itself. We should remember one thing before jumping on the next topic is carbon has a valency of 4. That means that carbon can bond with 4 atoms, or it can have 4 bonds. So in that regard, we have seen few examples where a carbon having 4 hydrogens is nothing but CH4. That is nothing but methane. If we have 2 carbons, already this carbon has one bond here, and we can have more 3 hydrogens. For this example I'm taking here, even this is also having one bond here, so it can have 3 more bonds here. So 3 hydrogens comes here. So this compound is nothing but C2H6, that is ethane. So before knowing the other topics, we should know the basics of carbon very well. At least we should know that the carbon has a valency of 4 and it can bond to 4 other atoms. That is what is important right now. Now, jumping on to the next part, what we have studied is we have started with, I think, classification. And in classification, we have seen the systematic classification of organic compound, as we have said in the previous discussion that due to catenation, the numbers are huge. So we need to classify them so that we can study them appropriately, or we can remember them appropriately. So classification has various categories. We have seen acyclic, cyclic, homocyclic, heterocyclic, aromatic heterocyclic, and in classification we have also concentrated on functional groups. We have also studied various classes of functional group, which starts with alkene, alkyne, alcohols, ketones, aldehyde, carboxylic acid, esters, halides, and so on and so forth. We have studied all those things, and also we have come across a term by name homologous series. What is this homologous series? We have already seen that homologous series are those compounds which differ from each other, by CH2 units. We have seen the example for this, that if you have, for example, CH3, CH3 is nothing but methyl group. How do you get methyl group? Methyl group is derived from methane. How do you get methyl group from methane? Methane is nothing but CH4. So if I remove one hydrogen from this compound, then it is equal to CH3. So methane loses one hydrogen to form methyl group. In the same way, ethane, that is C2H6, loses one hydrogen to form C2H5. The name now from ethane changes to ethyl. So we have seen these few things in our classroom. So we have also seen the importance of homologous series, importance of functional groups. I recommend all of you to please go through the notes and then we'll start up with the new topics. Okay. In classification of organic compound, we have seen till here. Then we have also seen few examples of nomenclature. And in nomenclature, we have seen few examples of how do you name a compound. Uh, the naming of the compound is given by International Union for Pure and Applied Chemistry, that is IUPAC. We have seen few examples. For example, here if you have 4 carbons here and you have OH here, you number from this side, that is left side, so that the least number should be given to the substituted carbon. And because it is at second position and the longest possible chain is this, the root word is but, that stands for 4 carbons. Because it is having only single bond, it is butane. But as it is having OH here, E is removed from here. E is removed from here and we add with position to OL, butanol. And because it is at second position, it is butane to all. So we have seen few examples. I just advise you to please go through those examples. We have also studied about isomerism. In that we have studied structural isomerism and we have discussed about types of structural isomerism, which is of 5 types. The first one is chain, positional, functional, metamerism, and finally tautomerism. After we have completed isomerism, we have started with a new class of hydrocarbons. What are hydrocarbons? First of all, hydrocarbons are those compounds which contain hydrogen and carbon. We have already discussed in our first beginning uh, class that carbon has 4 bonds, and if it is having 4 hydrogen, then the name is methane. But as you can notice here, this compound methane has carbon and hydrogen. So this can be taken as an example for hydrocarbons. These are hydrocarbons. So these hydrocarbons where we have single bonds, those hydrocarbons are called as alkanes. And the general formula for alkanes is CnH2n plus 2. With regards to this, we have first is methane, the second one is ethane. If I substitute instead of N2, then H into 2 instead of N, I am writing here 2 plus 2. Then is equal to C2. 2 into 2 is 4, 4 plus 2 is 6, C2H6. Likewise, we have propane, we have butane. It all depends on this general formula. We have also studied the structure of orbital structure of alkene, where we have understood that the hybridization in alkanes is sp3. The hybridization in alkanes is sp3. Why it is sp3? We need to remember this because P3 stands for, because p orbital contains three orbitals, px, py, and pz. If all the three orbitals are hybridized, then it is called as sp3 hybridized. Now you need to remember this: the carbon has sp3 hybrid orbital. That sp3 hybrid orbital overlaps with some compound, and that leads to the formation of a bond, and that is nothing but a sigma bond. Sigma bond is formed due to overlap of sp3 hybrid orbital with sp3 hybrid orbital, or sp3 hybrid orbital with s orbital. For example, we have the structure of this compound, that is ethane, and if I have ethane here, that is carbon and carbon with three bonds and three bonds, and as you know, all the three will be hydrogen. Now if I just want to explain you the orbital structure, it begins with carbon having sp3 orbital, overlap with another sp3 orbital of carbon. This leads to formation of a sigma bond. This orbital is sp3, this orbital is also sp3. This one is also sp3 orbital, and this will overlap with s orbital of hydrogen. Here also sp3 orbital of carbon overlap with s orbital of hydrogen. This is sigma bond. This is also a sigma bond. The same way here also. It forms a sigma bond here. This is due to this one is sp3 orbital of carbon. This is s orbital of hydrogen. Likewise here. This is the orbital structure of ethane, or we have taken this as an example for studying alkene. We need to remember a few things here, which I believe you have already studied for your internals. This is 1.54 angstrom is the bond length of carbon and carbon. Bond length of carbon and hydrogen is 1.09 angstroms, and bond angle is 109 degree 28 minutes. You need to remember these few things in this orbital structure. We have also studied after this is a concept or a type of reaction which we usually see in alkanes, that is nothing but halogenation. See, in halogenation, what have we trying to study is, halogenation is what type of reaction. We need to remember this because halogenation is a characteristic reaction for alkanes. And one thing we need to remember is alkanes are also called by name paraffins. Why are they called as paraffins? Because they will not readily react. They will not readily react because they are supposed to be more stable because of the sigma bond, which is more stronger. Okay, why they are not readily reacting? Because they are stronger or more stable, because it contains sigma bonds. Okay, this you have to remember the analogy or the chronology actually, where you need to remember why they are more stronger and why they are not participating in the reaction readily. But you need to remember one thing here is, for example, here I'm just taking an example of methane, that is CH4 reacts with halogens. What are halogens? Chlorine, bromine, iodine, fluorine. These are all examples of halogens. If this alkane reacts with chlorine, then it is called as chlorination. If it reacts with bromine, bromination, iodine, iodination, fluorine, fluorination. So here what happens here is this CH4 reacts with Cl2, in the presence of UV light and delta is temperature, it gives you CH3Cl plus HCl. What is CH3Cl? That is nothing but methyl chloride. Methyl chloride is formed when methane reacts with chlorine in the presence of UV light and at higher temperatures. What has happened in this reaction? Out of the CH4, we are replacing one of the hydrogen with chlorine. Are we doing that or not? Yes, we are doing that. That is why this is what reaction? It is a substitution reaction. The reaction name is substitution reaction. We have seen the mechanism of halogenation where the reaction proceeds via formation of a free radical, and we have studied how a free radical is formed. Free radical is formed when there is a homolytic fission. A bond, we'll start with this first, that chlorine molecule is Cl2. I can write the Cl2 in this form, Cl bond Cl. A bond has two electrons. If I'm able to divide this equally, then I'll get Cl with a dot, that is nothing but electron. That means this electron goes to this one, this electron goes to this chlorine atom. I get chlorine free radicals. And we have studied about chlorine free radicals and various steps involved in the halogenation reaction. And here if we are using chlorine, that it is chlorination reaction. We have we have studied three steps. The first one is chain initiation step. The second one is chain propagation step. And the final one is chain termination step. So nothing but by the name itself it suggests that chain initiation is nothing but the reaction is started, and propagation, and that means it is moving forward, and termination means how the reaction is ending. We have seen the mechanism also. If you have got any problem in understanding the mechanism and all, I will ask you to just message me, or I'll once again give you the explanation for the. Just let me know if at all you need the explanation for the mechanism for halogenation. This was the introductory part, what we have studied till now. Remaining things are many things which we have to cover, and don't worry, we'll try to cover it as much as we can with the help of this platform. We'll start up our class with alkenes introduction, and in alkene introduction we'll see what else we can do. For the beginning class, I just wanted to give you an introduction and just know the uh, review from you whether this platform is good for you. Are you able to understand it or not, or do you need any changes in this? But whatever changes are there, we'll try to inculcate slowly. But just for the sake of beginning our classes, I've made it this